Today we're looking at a couple of different news items. The first one is a 3D printed sweat collector. So this is from the University of Hawaii, and it's a part of something for a new generation on-the-body sensors. And what they've done is they've used DLP to make a 3D printed sweat collector. Now the idea is that at one point, we've all seen that smartphones can now monitor your steps and many more vital signs. There's fitness monitors, and people are looking at a way to put all sorts of sensors and things on the body. And this paper, which is from the University of Hawaii, is about a skin interfaced microfluidic system with spatially engineered 3D fluidics for sweat capture and analysis. This is from Chung Han Wu, Howen Yang Hingma, Paul Bessler, Roxanne Kate Balneray, and Tyler Rebrider. It was published in Science Advances, and it's called the Sweatainer. So congratulations for the really catchy name. The idea is that it could collect sweat, and then it could be used for diabetes testing, perhaps heart disease, maybe to check if people are hydrated. And there's two different things. One is that these separate chambers that you can see here can all individually collect sweat. And that could then be taken out by a testing device. So 3 different collectors of sweat could be used throughout the day or whatever. And what we can do is put 3 different reagents in the sweatainer. So for example, if your blood sugar would be too high, the one chamber would become green or something like that. And if you'd be dehydrated, the other chamber would become red, telling you to drink more. I think it's just this works through 3D printed microfluidic channels, and and I think it's great that it's a DLP 3D printed component, so it could be really cost effective. It could be a really cheap thing that a lot of people can make. Now, I don't know if sweat collecting sensors is going to be a thing that is going to define the future, but I love the idea of on the body patches and skin sensors and these kind of like temporary sensing things. Imagine for like a military or people that live in very humid or hot areas, but also a company like FedEx or something like that. It would be really great to just tell your employees that they're not that they're hydrating enough. Something simple like that could really be a really great kind of application for this. But just generally, I think we would love to see more applications, more areas where something like this could be used. And yeah, if it's just a DLP regular kind of print, then it could be quite cost effective as well. The next item is from Nuburu or Nuburu. I still don't know how to say it. And that's a company that makes blue lasers, and it signed a technology agreement, a joint technology agreement with GE Additive. So this is the idea of implementing Nuburu's green or blue laser technology inside a GE Additive machine. Now, the obvious thing to do here is to print copper and aluminum. Green lasers by Trump and other companies have been used for these kind of materials, generally higher brightness, just helps overcome some of the problems we have with these really highly reflective materials. Now, the specifically this blue laser company hopes that it would have less spatter and it'll be able to print at higher speed. Now, the other thing here is that Nuburu is an American-based company. This would mean that they have a U.S.-based solution for for 3D printing copper and these really high-end combustion chamber and other parts that can be used for rocketry. And that would be really interesting, of course, for US-based space companies or US-based defense firms or satellite firms to use a completely US-based technology. This is also under a part of an AFWorks kind of project, Small Business Innovation Research Project, SBIR Phase 2 contract that Nuburu got in 2022. The next work comes to us from, it's about 3D printed concrete. But it's about solving one of the key issues of 3D printing concrete. Now, we don't know if we have the right strength for this kind of process and if we have the right properties in these parts. And there are some microstructural issues when we print concrete. There's like a thin film of water and other stuff around the extruded material. And that could change the microstructure to the point where it could propagate cracking. Now, university researchers at Princeton have looked at a testing methodology that uses cuts with lasers to make grooves in particular locations. And the idea is that through controlling the power and the speed of this laser, they can control features and feature sizes like groove depths and shape, and then develop better tests to hopefully develop stronger 3D printed structures going on. This is from Reza Moini, Shashank Gupta, Aryan Prihar, and Hadi Esmaili. And these guys have come up with something that, usually we don't talk about testing and these kind of things, but this is really, really valuable in this kind of scenario. So I really think this is a good thing, especially since people want to make like multi-story car parks and houses with this stuff. Anyway, this is 3D Printing News Unpeeled. My name is Joris Spiels, and this is thanks to 3dprint.com. Have a great day.